So now we've looked at the difference between compass bearings and true bearings, let's look how we use these in applied questions. So let's begin. Now the first question we're going to have a look at is, a plane flies on a true bearing of 98 degrees true and is now 90 kilometers east of its original starting position. How far has the plane travelled to 2 decimal places? Now the biggest thing that I see trouble people with these sorts of questions is to first understand the information that they've been given and draw a diagram of the situation. So let's look at some strategies that I personally use to do this. Now the first thing that I do is go through the question and highlight the important information and getting rid of all the guff that we don't need. So in this problem, let's read through it. A plane flies on a true bearing of 98 degrees true. This is important and is now 90 kilometers east of its original position. So now 90 kilometers east is what we need to know. How far has the plane travelled to 2 decimal places? This is all pretty important. We will use that once we've recorded our diagram. Now the first thing that we need to do is record where the plane's going to start. And I've already got a compass here to help us. And we're going to start right in the centre of the compass. So this is our starting point. Now we know that the bearing we want to travel at is 98 degrees true. So 98 degrees true will actually be past the east, because that's 90, and it'll just be a little bit past it. So we'll go out here somewhere and it'll finish just here. Now it doesn't matter how big you draw this because it's not to scale anyway. But the next thing it's told us is it's now 90 kilometers east of its original position. Now the wording of this is very important. It's 90 kilometers east. It hasn't travelled 90 kilometers, it's 90 kilometers east. Now I've drawn my east direction just here. So what it's actually telling us is that this side here of the triangle I just drew is 90 kilometers long. And what do we know about this triangle I just drew? Well, we know that this angle here is a right angle. So we've just drawn ourselves a right angle triangle. Now let's read what the third part of this question was asking us to do. How far has the plane travelled to 2 decimal places? Now how far the plane has travelled is the line that I drew solidly here, and I'm going to call that D for distance, because I don't know what that length is yet. But I now know that I've got a right angle triangle here. So I'm going to draw a rough 90-degree triangle here and enlarge it a little bit. So let's put my information in. That's 90 degrees, this is 90 kilometers, and this is D. But there is one more bit of information that we can work out, and that's what the angle is here. Now we know that the angle between the north and the east here is 90 degrees, and the true bearing it travelled at was 98 degrees. So the difference must be this angle, which is 98 subtract 90, so it's going to be 8 degrees here. So now we've got our right angle triangle, we need to use some trig here to solve it. We start by labelling the sides. So this is going to be our hypotenuse. This here, because it's opposite our angle, is our opposite, and the remaining side is our adjacent. Now to work out what trig ratio we need, we quickly write down our SO, CAR, TOA. We record the information that we have. So H equals our unknown of D, A equals our 90 kilometers, and our theta equals 8 degrees. So we're looking for the ratio that has the adjacent and the hypotenuse, which in this case is going to be our CAR ratio, or cos ratio. So let's record what the cos ratio is, which is equal to cos theta equals adjacent over hypotenuse. So now we substitute the information that we have. Theta equals 8 degrees, so it's going to be cos 8 degrees equals the adjacent of 90 divided by our h of the unknown d. And now it's time to rearrange it to isolate our unknown d. To do this, we multiply both sides by d first. So multiply here by d and that will cancel. Multiply by d here. So d cos 8 degrees equals 90. And now we need to divide both sides by cos of 8 degrees. So here this will cancel and leave us with d on the left hand side, which will be equal to 90 divided by cos of 8 degrees. And when we put this into our calculator, we find that d is approximately equal to 90.88 kilometres rounded to 2 decimal places. So now we've had a look at that question, let's try one more. In this one, Steve goes sea kayaking on the weekends. He paddles on a bearing of south 58 degrees west for 2 kilometres. How far west, correct to the nearest metre, is Steve from the start? Now just like last time, let's start by highlighting the important bits of information and getting rid of the guff. Now in this case, Steve goes sea kayaking on the weekends. Not really important for us. He paddles on a bearing of south 58 degrees west. That is important. For 2 kilometres. Once again, very important. How far west? That's what it's asking us. How far west to the nearest metre is Steve from the start? So just like last time, let's start by drawing a diagram of this. Let's put the starting value right in the middle of our compass. Now the first piece of important information said that we're travelling at south 58 degrees west. So to determine that, we start at south, we go to 58 degrees in this direction, and we draw a line out and then put a finish. Now we went on that bearing for 2 kilometres. So the 2 kilometres is that line that we just drew. How far west has he travelled? Now west is going to be that direction here from the South Pole. Now we want to know how far west it is. So I'm going to put a W along that line. And what we've found is we've got ourselves a right angled triangle here. So I'm going to draw this right angled triangle so it's enlarged with the information that we need. So it's 90 degrees here, it's 58 degrees in here. We travelled 2 kilometres along this line and we're looking for our unknown there. So now we're going to use some trig to solve this. So we write our memoriser for trig, so ka toa. And now we start by labelling our triangle. Start with the hypotenuse. We look at the angle. Opposite is where the W is. So adjacent must be the one remaining. So now let's record our information. We've got our hypotenuse, which is equal to 2 kilometres. We're looking for our opposite, which we've labelled as W. And we've got our angle or theta, which is equal to 58 degrees. Now which one of these three have both the O and the H? It's only SO, or the sine ratio. So the sine ratio says that sine theta is equal to the opposite over the hypotenuse. So now let's substitute our values. So that means sine of 58 degrees is equal to the opposite of W over the hypotenuse of 2. So now we want to isolate the W. So we need to get rid of the divide by 2 by performing the inverse of multiplying both sides by 2, which on the right hand side leaves our W, on the left hand side leaves 2 sine 58. So therefore when I put this into my calculator, our W will equal 1.696 kilometres. Now if we look back to the original question, it asks us to answer this to the nearest metre. Now there's 1,000 metres in 1 kilometre, or 3 zeros. So what I need to do is leave 3 decimal places when I round, like I have here. So now I have some problems here for you to have a go at. Remember, start these questions by highlighting just the important information and get rid of the guff. Then draw a diagram starting with a compass point and your starting position. Measure out where the bearing is talking about, draw a line and put your finishing position. finally, put all the other information that you know onto that diagram. I always find it easier then to draw a separate right angled triangle and putting your information onto that before trying to use our trig ratios.